Here we have another exercise 2.2, also on the flash separation. So the problem is about a mixture of 58% of acetone and another 58% of water, and it has to be separated into two streams, one enriched in acetone and the other enriched in water. So the separation process consists of extraction of the acetone from water using methyl isobutyl ketone (MIBK), which will dissolve acetone, but it is immiscible with water. Okay. So what you need to do is you have to first simulate the process using SRK property method, with the overall goal to separate the feed stream into, as we mentioned earlier, one stream should be enriched in water. So possible, the purity of the water must be more than 90%. Okay. The other is a stream which is enriched in acetone. Okay. So after you simulate the process, you need to determine the composition of the product stream. Right. So second, you have to generate the TXY diagram and also the PXY diagram. So the input specification for the feed stream as well as for the unit operation. The important unit operation here is the flash drum. So if you look at feed stream, it consists of 58% of water and acetone respectively, with the temperature of 25 degrees C and pressure of 50 psi, and the mass flow rate is 100 pounds per hour. Right. So we have another feed stream here. You have two feed stream because you need solvent, the MIBK, to extract acetone from water. So MIBK here, the temperature and pressure are the same with the acetone feed stream, and even the feed flow rate also the same. And then we have the specification for the flash drum. Temperature 25 degrees C and the pressure is 50 psi. And as mentioned earlier, you have to use SRK as property method. And when you use SRK as property method in the free water method, you have to change it to steam NBS, okay, as your method. So this is to predict the property of the water. Right. So let's analyze the problem before you solve it on your own. Based on the process description, the unit op that we should have in the process flow sheet is the mixer to allow the extraction happen, and the flash tree model to allow the separation of the two liquids and vapor. We are having two liquid here because we are having MIBK and water, which are immiscible, and because of this, we have to use flash tree to allow the vapor liquid equilibrium to occur. So in terms of simulation step, as usual, you have to add the chemical component, then you select the thermodynamic model. Okay. In this case, it's SRK, and remember to set the free water method to steam NBS. And then we add the unit operation, the flash drum, and also the mixer. Okay. Then you, of course, you add the stream as well. Then you specify the user input, the feed information, as well as the unit operation information. Then you run the simulation and check the results. So this is the graphical representation of the overall process. Okay. So we have first we have water, okay, with acetone. The acetone is our desired product. It is in water. So we introduce MIBK here and let the extraction happen in the mixer. So after the extraction, acetone supposed to go to MIBK based on the affinity of acetone with MIBK, and then we have two layers here because of the immiscibility of MIBK and water. So with this, we push it to a flash vessel, and this flash vessel should allow to have 3 products. So 1 vapor at the top and 2 liquid at the bottom. Okay. So this is how you need to put the flow sheet in Xpen Plus. So we have here, this is mixer. Okay. B1 is mixer, and then we have B2 as a flash 3 model. Okay. So your task, as I mentioned earlier, or as stated in the question earlier, you have to first simulate the process and determine the composition of the product. And then you have to generate the TXY or the PXY diagram. Sorry, it's and you have to generate both. But I have actually given you some hints over here to generate the TXY and also PXY diagram. So what you need to do is you have to go back to property environment, and then under the analysis you have to choose binary, okay, to allow the binary analysis. Then you select the type of analysis, select component, and then run the analysis. So over here we would like to have the binary analysis, the TXY diagram. Just choose a TXY diagram here in between acetone and MIBK, because we would like to know after the process of flash separation, how are we going to separate the acetone from MIBK? Can we use a normal distillation column, or we have to use azeotropic distillation column, or we have to use another extraction to separate these two, right? Okay, now once you have all this, then you just run the analysis. You'll be getting the TXY diagram for the MIBK and acetone. So based on the TXY diagram, what does the diagram imply? Okay, and then any azeotrope form. Based on the diagram, can you answer whether any azeotrope form? If there's no azeotrope form, what would be the best method for you to separate acetone from MIBK? So I will leave it to you to answer all these questions based on your chemical engineering thermodynamic knowledge and also unit operation knowledge. So these are the take-home messages and also homework. Mentioned earlier, you have to complete exercise 2.2, and with the completion of this session, you should be able to simulate the flash separation using flash 2 and flash 3 model. And then you should be able to perform the sensitivity analysis, which is one of the model analysis tools to identify the best operating condition to fulfill certain criteria, for example, the product specification or product composition. And the third one is you should be able to carry out the property analysis, like binary analysis, TXY, and also PXY diagram. Okay. So with this, I thank all of you, and I hope you can complete exercise 2.2 and take the message home. Thank you very much.